What's poppin', dogs? Mr. Allen here with some application of non-right triangle trig to find the area of this quadrilateral here, quadrilateral A, B, C, D. Now, unfortunately, this thing's not a rectangle, it's not a parallelogram, trapezoid, anything that we know how to find the area of. This thing's all sorts of jacked up. We only have 3 known sides, 2 angles here, so how in the heck are we going to do this? Well, I can divide this quadrilateral into 2 non-right triangles, find those areas, and just add them together. Unfortunately, we don't have enough information right off the bat. But I can divide this thing into 2 triangles, either going from B to D or A to C. There's no wrong way of starting it in that one. You can divide it with either one. The math is going to be a little bit different along the way, but we should still get to the same answer. I'm going to go from B to D on this one. And an important thing to note is that it's not splitting it perfectly in half when it's just a quadrilateral. Okay? If it's a parallelogram, it does. But for a quadrilateral where it's not the same thing all around, 2 totally different triangles here. Now I could right away get the area of this triangle. I have a side angle side situation, so I can use that sine formula with that one, get the area. I'm going to hold off till the end because there's a lot of math that's going to go on with this one, and then I can just add that one right at the end. Okay, so let's deal with this triangle first. I need some information. So this green diagonal here splits that 70-degree angle, but not perfectly in half. I need to figure out what that is, because I want to get a side angle side situation on this triangle ABD right now so that I can calculate it using that sine formula. So let's do this. First thing I'm going to do is find out the length of this green line using some law of cosines because I have a side angle side situation. I'm not even going to write it out because I'm going to run out of room, so we're just going to type it all into the calculator right now. Okay? If you remember, you can even do the square root of, I usually don't remember that one, and then I can put in the law of cosines here. 11 squared plus 21 squared minus 2 times 11 times 21 times the cosine of that 105. Close my parentheses. I hope I'm in degree mode. I didn't check. All right, let's see here. Let's double check. That seems right. Yep, I am in degree mode. Okay, cool. So that's my length of this guy right here. And that seems logical, right? It's the biggest angle of this guy here. So it's got to be the biggest side, and that's bigger than 21. So 26.1069106, and I always put a little ... at the end because I'm still going to be mathing with that thing, right? So I only want to round once when I do this thing. I know this is backwards now, but yo-ro, you only round once. So that way it's more accurate along the way. If I start rounding to the nearest tenth and calculating, things are going to be off, and it's going to be a slightly different answer. We don't want that, okay? We don't want that. We want accuracy, okay? Details matter, bro. All right, so now what can we do here? Well, I could, because I need this length here, I could figure out what this angle is here and subtract it from 70 to get this angle here, because then I have a side angle side situation for this triangle. I have a side angle side situation for this triangle. I'm good to go, man. All right, so that's my move. That's my move. I want to figure out what this angle is right here. We'll call this, I'll call it X. Okay. Well, I have a side across from that angle, right? That's good. And I have a side across from an angle. So I can use law of sines for this. I actually like to write this one up. So we'll do sine of 105, sine 105 over its known side, 26.106 and change, equals, and then sine of the guy that we don't know, sine of X over the 11. We'll cross multiply solve. So it's going to be 11 times sine 105 equals 26.106 sine of X. Feel free to do some shortcuts here, and minimize a little bit of your work that you're doing, because there's a lot going on here. So if you can kind of do some algebra in your head, it does help save a little space on your paper, but I'll write out most of it here. So here I'm going to have all this needs to go into sine inverse, right, if I want to solve for that X that's inside my sine function. So we'll hit second sine here, and then I'll even type a little fraction so it's nice and easy. 11 times the sine of 105, close my parentheses, divided by, and then here's what we got to do here. Because I typed it in like this, I can't arrow up. It'll put it in the numerator, which kind of stinks, okay? So you can either do just division, or what you can do is this, since I already have the fraction in there, 11 times the sine of 105, close my parentheses, and then if I hit second then the negative key that says ANS, it's going to put in the previous answer, which is the 26 and change. Boom, there we go. We got 24.015 and change degrees. I could have also done it like this, like I was saying, 11 times the sine of 105, close my parentheses, divided by, then I can arrow up, and it will put it where I want it to go. Hit enter, I get the same thing, right? Almost the exact same thing. We have it slightly different right at the very end, the tail end there. All righty, cool, beautiful, fantastic. All righty, so we've got ourselves 24.015. 24.015 and change degrees, which means what's this angle right here? That's what I really want. We're going to do 70 minus that angle, and I've got 45.984. 45.984 and change for this particular angle right here. And now guys, I have enough to find out both of these triangles, okay? Using my fancy non-right triangle area formula, which is 1/2 sine of the included angle. I'll do the one that I just calculated first because it's right there, times the 16 times, and then I got to go up and get that 26.106 and change. Hit enter. That's triangle number 1. That's this guy right here. I'll even write that in there. All right, and that's why I really like to use the arrows, arrow up, get those answers. It's more accurate, and I don't have to type all that stuff in. Plus, I feel like a boss doing it. I'm like NASA accurate right now. Area equals, we got 150.198 and change. We'll round it once at the very end. Only once. Yo-ro. Only once. And then we've got the first guy here that was really easy to calculate if I wanted. And now you can see, like, why would I want to do it all the way? Earlier, I'd have to, like, arrow all the way up and, like, find it again. So I just saved that one for the end. Right? So 1/2 times 11 times 21 times the sine of the angle, which is 105. I don't know why I typed it in kind of weird last time with the sine first, but it's multiplication, so it really doesn't matter. Usually you see it as 1/2 times the side times the side times the sine of the angle. I don't know why I did that. It's weird. We get 111.564. So pretty close, it relatively to the same area. Not really. Both in the hundreds. All right, now let's add them together. So plus, and then I'll arrow up, grab this guy here, hit enter, and my final answer, the final answer here for the area is 261.76. 176, and this is in feet, so feet squared. Boom. That's awesome. That's awesome. All right, man. So a lot of fun stuff. So it's on my face right now. Non-right triangle trig coming at you, man. I do enjoy these problems, right? Split it this way. You could have split it from A to C. You would get the same answer. You would just see some different areas and other calculations along the way. Feel free to try that way. See if you get the same answer. See if you're mathing it correctly or not. But there we go, guys. Area of a quadrilateral. The same would work out if you were doing a parallelogram. It's just when you split a parallelogram, you get two congruent triangles, so you only have to double the area that you find for the one. So that's kind of nice. All right, that's about it. You guys have a wonderful day, and see you later.